so much for joining us today. This is our section's first webinar. Earlier, it was the AATCC Midwest section, and we revived it, and now it's called the AATCC Great Lakes section. So just a short, brief introduction about my section. It includes states of Michigan, Minnesota, Wisconsin, Ohio, Indiana, and Illinois. And we also have committee members from Colorado and Kansas. And we just started this June of 2025. And we came up with our newsletter that was distributed to all of you this month also. I hope you got a chance to review it. So just a short introduction. My executive committee includes me as a chair, and then I have Cameron Henderson as the vice chair, Audra Hunter as the secretary, Dee Lamberty as the treasurer. We have Dr. Gashti, who is also moderating this webinar as our section education chair. Then we have Lauren Agnew, education chair from Central Michigan University. And we have Lauren Hickey. She is from Cleveland, Ohio. She's our events chair. And then we have Stephanie Rogers, who is also our section's events chair. And plus, besides that, we have our section's newsletter committee that comprises of students that are also led by Dr. Gashti. And they are doing a wonderful job, and that's how they came up with our section newsletter. So today for our inaugural webinar, we'll start with our presenter. So I'll give it all over to Mr. Gashti to start from here with his introduction. Thank you.
Yeah, thank you so much, everyone. Actually, this topic is about sustainability. Since we actually ran the survey, and looks like this topic was the highest topic, among the voters, and then we picked this as a first. We have actually priority from different topics to discuss for, and also in terms of the numbers we can run per year. We like to have more speakers engaged, and also it's about integrating the science and technology and knowledge spread in the country. But I actually wanted to shortly introduce Mr. Dave Kasper, Vice President of Sales and Product Development. And Dave actually started his career in textile industry since 1989. And since that time, he has been engaged with different knitting and dyeing processes in Canada. And also now he's engaged with actually recycling of workwear materials, mainly focusing on firefighters, and also this topic was about the topic is textile innovations, closed loop recycling of flame resistant workwears, and it's more about Nomex and also higher performance firefighter gears, how they can be recycled since they are actually highly added value product. And I just leave it to Dave to start.
Thanks, Maz. Appreciate the opportunity to address your organization today. I'm always happy to talk about FR garment recycling, and it's a topic that flies under the radar screen of most discussions today when it comes to recycling textile waste. Let me back up one more slide. So closed loop recycling of FR workwear, and in my world, FR stands for flame resistant, not fire retardant. And there's an important distinction that we can talk about as we go through the process. So our main focus is on aromatic polyamide, meta and para aramids, and you're part of the Chemist Society, so I'm assuming you all know about the chemical structures behind meta and para aramids, and we're focused on them for a couple of very specific reasons. One is they're an incredibly strong fiber. The byline is Kevlar. You see on the screen there is 5 or 6 times pound for pound stronger than steel. Nomex is less so. It's also strong fiber, but not as strong as Kevlar, but it brings some exceptional thermal protection properties to the conversation, and primarily reasons why it's used for protection against flash fire in the industrial workwear setting. It also happens to be 100% non-biodegradable, nor should it be incinerated, because the chemical structure, of course, behind that is the aromatic benzene ring, and it's toxic. So what do we do with this stuff? typically it goes to landfill. And every inch of it that's been produced since the early 1960s and DuPont's invention is in the same state it was in from the time it went into the landfill. So back in 2011 or 2012, my partners and I started working on the possibilities to recycle these materials. So what you know, I'm going to show you over the next 20 minutes and talk to you about over the next 20 minutes is just how we do what we do, of course, the closed loop programming, why it's cost effective, and how we scale it up with various end users out there. The industries we're talking about are, oil and gas is the low-hanging fruit. All refineries in North America, all refineries in the world are spec'd into meta-arament products, hydroelectric, electrical utilities, chemical production, wildland fire, structural fire, automotive, military. Once you start scratching for armaments, you find it everywhere, and workwear is only a small component of it, quite frankly. We work with different fiber blends. The typical product we see on the market is a blend of 93% meta-arament, 5% para-arament, and 2% anti-stat. But you're seeing a lot more fiber blends in the market that'll involve flame-resistant viscose, so other cellulosic fibers that have been re-engineered to bring flame-resistant properties to the table. Modified acrylics, another example. We see those blends all the time, and we're happy to work with those blends. It's not a problem. Because we're talking about standards in the workplace, labels are a critical component to any workwear garment in the field. Nobody would put a garment on their back without having the proper labeling on it. So we're able to stay very consistent with how we recycle product. Some of the things we worried about, you see them on the list there. The adaptions to the garments, the hook and loop, which is Velcro, or polyester pocket inserts, or interfacing, elastics, things of those natures. We have to remove all those materials before we shred anything back into fiber. You can see that picture on your right hand side. I couldn't figure out a good place to put it, but seeing as you're the Chemist Society, I thought you would appreciate some of the humor behind this. Perhaps it's more suitable elsewhere in the document, but I'm going to explain it anyhow. Color is important. Corporate colors, branding. You guys, we deal with that kind of stuff every day, and you deal with it in workwear too. But the importance of it is relative to who you're talking to within that organization. This picture you see on the right came out of Red Deer, Alberta, and we were working with the companies supplying these garments to Schlumberger, and they were giving us some grief about the color of our recycled royal blue. And how it didn't fit their corporate branding. It just so happens we got a shipment in from that company that very day, later that afternoon. So we spread some garments out on the floor, and we took a picture and we sent it to them, and we asked them to identify which shade of royal blue that we were not achieving. Very much tongue-in-cheek, but the message was sent and received quite well. In other words, in the boardroom, yeah, your color is important, but out in the field, 50, 100, 75, 100 commercial laundries, dry cleaning or wet wash, doesn't matter. The things that they're exposed to, color very much does not make a difference. The level of protection does, and that's what was key. And we could talk about more as we go forward. So what does closed loop mean for us? So we work with end users. Right. I think it's a key point is I don't take anybody's garbage. I'm not interested in it. And once it's identified for landfill, that's exactly what it is, garbage. And if they don't know what to do with their garbage, frankly, what the hell am I supposed to do with it? If I start collecting people's garbage, I will be up to my rafters with product with no avenue to bring it back to market. That's where the closed loop comes in. So we will collect garments, work with the end users to identify how best to collect garments with their current value chain. We do all the separation and the deconstructing of the garments, the zippers, the snaps, and all that good stuff. We will mechanically open the fiber. You see it there. We have an aramid specific shredding facility in Canada. It's based in Quebec. and that's where the textile infrastructure is in Canada, and that's why we're located there. And it's very important to recognize that it is built to be able to handle para-aramids. Para-aramids eats machinery. So a conventional textile shredder, excuse me, aramid fiber would blow through a carding system in a matter of weeks if you're not built to specifically handle aramids. And those are $100,000 fixes. So it's not something to take lightly. So we collect the garments, we open the fiber through our shredding process, and then we will work with an end user's value chain to spin the yarn, weave or knit the fabric, and ultimately the garment supplier would continue to make garments for the end users that has recycled content in the blend. Everything is third-party, independently certified to meet the applicable NFPA or CGSB standards. Flash fire, electrical arc flash, wildland fire, etc. They would be the three that are considered the low-hanging fruit, in my mind, anyhow. So when we take garments in, we work through that collection system. We take garments in. We're making sure each garment is handled individually. We are removing products that, for some reason or another, might not have a label on it. It's pretty rare on the label side, but we look for that. We will, anything that is, we look for residual chemicals on the garments. Basically, if they smell, we know there's something on the garments. So we can clean them. And cleaning, they're always clean before they come to us, but we will clean them additionally if we need to. And depending on what the type of contamination they've been exposed to, will determine how we wash them. Hydrocarbon contamination will most certainly be dry cleaned. Something that's more of a particulate contamination, wet wash is probably sufficient. So we screen for that. And then there's physical verification. If anything is overly stained with paint or silicone, or again, depending on the industry they're coming from, those portions can be cut out. That's really a critical step, the inspection stuff, before we get moved to deconstructing the garments. I'm just going to bump ahead here for a second. Yeah, okay. Operations and Q&A, it speaks for itself. We're very particular about how we very consistent and very particular about how we collect garments and clean them. The bottom point there, companies, and what's the best word to do it? Education is a key component to what we do. And we need to make sure that gets to the shop floor as well, because if they see a bin, they see a collection bin, however that is determined, we get everything in there. And trust me, we get everything. But we're not a garbage dump. So when companies, so we make it very clear to end users, if you're going to send us crap, we're going to charge you back for it, right? We're not going through the, we're not a disposal company for everyday garbage. We pay really close attention to that. So the first step in the process after we've sorted the garments, decontaminate the garments, we're removing zippers, snaps, and because we're talking about standards here, those are brass components, and that brass can be recycled, and it is recycled. High visibility striping on the garments, it really depends on what's coming at us. Sometimes if you just imagine the yellow striping with silver reflective on there, the yellow is oftentimes cotton and monocrylic blend, and the silver reflected is in fact very minute glass bead. The glass is inherently flame resistant, so we have left it on before. Our shredding process will eliminate short staple fiber. The cotton staple tends to be too short. It is too short for our process and will be filtered out. At the start of our process, we have carbon blade cutting systems. Again, the aramids are very hard material to deal with. So these carbon blade systems work at very high speeds, cutting the garments and the fabrics into smaller, more manageable pieces. We also do it by hand at our facility in Alberta. And frankly, our guys prefer the hand method as opposed to the carbon system. The material is so hard on the blades, they require sharpening every 3 to 4 hours through processing. Once it goes through the carding system, once it goes in through the cutting system, They're accumulated in what we call our blending box. And we'll load somewhere between 5,000 and 7,000 pounds of material in the box before it starts being drawn into our Titan tearing systems. So essentially going from the initial stages tearing to finer to finer to finer to finer until we get into our until we get to the baling of the fiber itself and off to the yarn spinner. So and the twin carding that you see there is part of the process. So it starts with very coarse tearing, it gets finer. We have a pneumatic filtering system built into the line that is pulling out short staple fiber and dust, or any larger pieces that haven't been torn properly get redirected back to the start of the line and then go through the process again, ultimately into the twin carding systems. So here's the final stages of the fiber preparation, where the fiber is carded to a degree prior to baling, so that once it is baled, it's ready to go to the yarn spinner, blending, and then spun into yarn. Producing virgin aramid is very labor intensive, and helps us make the economic argument why we can recover enough of the fiber to make this a viable expedition. Without a doubt, we operate our facility in Quebec is a carbon neutral facility. We only use renewable hydroelectricity. There's no chemicals involved in our process at all. We are strictly mechanical recycling. We've got 90% fiber recovery listed there. Frankly, it's been a little bit higher, but we're kind of shocked at that number. But you know, we have at times achieved 95, 96, 97% fiber recovery. And the material that we do recover are our waste material, which is primarily dust or very short staple fiber. We have uses for, and we're in the lab process now. We also have a provisional patent on recycling thermoset plastics, where we're introducing some of these some of our byproduct into new polymers. And it's really premature to be talking much about it, but we're working on reducing that waste stream even more. And of course, the cost integration. So when we work with end users, rarely would I ever talk to procurement about things anymore, because if I ever ask them what does it cost them to dispose of a garment, they look at me cross-eyed and you know, say, what are you talking about? The guys come in, put the garment in the bin, off it goes. Well, if you get the waste management guy in the room, he will tell you they have to handle the materials, there's cleaning the materials, there's transportation involved, there's landfill fees, which are probably his easiest problem. The point being that there's, you know, $5 or $10 floating around in overhead somewhere that's directly related to that PPE. So we will work with them to identify those costs and then work them into the recycle program. We work with the existing value chain. Like, we're not interested in disrupting that. We recognize that that those relationships are hard fought, hard won, and long-standing, and we're not looking to upset that. So we're looking to feed that fiber back into the value chain that's already producing garments for them. And this is the key part of our program. The end users can drive that discussion. None of the value chain will offer a recycling option. None of them. And they don't, for simple reasons. One, they don't have to. That's number one. Number two, why would they introduce a new product into the process that competes directly against their primary SKU in the marketplace? They won't do it. There's just no incentive for them to do it. But if the end user says, we want 25, 30% recycled content in our blend, then they've got every reason in the world to do it. And frankly, nothing changes for them, because the fiber, the yarn, the fabric, and ultimately the garments that go back to the end users now with recycled content have all been third-party independently certified at the very same testing facilities that do the testing on the virgin product. So nothing changes for the value chain at all. And that's a really important point to stress. And in fact, we incorporate the garment manufacturing and the fabric guys into the recycle process, and that we take their scraps as well and work that into the system. I don't know if anybody knows much about a cutting room floor and cutting garments, but a coverall in particular, you can all imagine a coverall where when you lay out the fabric rolls on a cutting room table 10 meters long, 100 plies high, put your pattern down, whether it's laser cut or hand cut. On a coverall is a really crappy yield, so 10 to 15% of the product goes right to waste. Those are all virgin fibers right now, every day going to landfill. They can all be recuperated and put back into the process. Just going to take a drink of water. Give me a moment. So then the numbers you see on the right are DuPont numbers. They're not ours. You can see the standards that the basic standards that we would deal with every day. NFPA 2112 is National Fire Protection Association 2112. That's the flash fire standard. National Fire Protection Association 70E, that's the electrical arc flash standard. And 155.2 and Z462 are the Canadian versions of the 2112 and 70E. The numbers you see on the right are come from a DuPont test that they performed a few years back at the Petroleum Safety Conference in Banff, Alberta. So these are the oil and gas guys from around the world that come and hang out for a few days a week in Alberta and beautiful Banff. And the DuPont brought along their thermal man testing unit, and they asked us if they could fry one of our garments with recycled content. The key difference is 4 second. You see up there 4 second mannequin burn. The actual certification to NFPA 2112 is a 3 second incident flash fire at 800 degrees centigrade. And they're measuring the combined 2nd and 3rd degree body burn on any one given fabric. DuPont likes to test to 4 seconds because of the cotton nylon name you see there. I'll keep the brand names out of it. Now, there's a correlation certainly between weight of the fabric and performance. And the first garment they put on the market on the mannequin was a 9-ounce cotton nylon, 275 grams, and cotton. The mannequin has a cotton T-shirt underneath and cotton underwear. 122 sensors on the mannequin, and they are measuring the combined 2nd and 3rd degree body burn. So why do they test at 4 seconds? Because at 3 seconds, the cotton nylon 9-ounce product performs very well. Probably in the neighborhood of 2 to 3% 2nd degree body burn. At 4 seconds, however, it's more like 90%. So your worker is alive at 3 seconds, but he's dead at 4 seconds. But the standard, of course, the flash fire standard is 3 seconds. And why is it 3 seconds? Because the average or the typical flash fire, and those words get used a lot, is under 3 seconds. It doesn't account for a secondary fire, or if it happens to go a little bit longer than 3 seconds. And DuPont is pointing out that their product performs better at 4 seconds than 3 seconds. Virgin meta-aramid product with a 93 meta-aramid, 5% para-aramid, 2% anti-stat would probably have about 18 to 20% combined 2nd and 3rd degree burn. That's how they would report it. So the first garment up was the 9-ounce cotton nylon. The only thing left of that garment was the Nomex seams, the thread seams that were used to sew the garment together. Everything else was gone. The second percentage there, you see 37%, was a virgin aramid product. I think it was about 5 or 7 year old garment, and they had combined 37% burn. And then the third garment they tested was ours. And our garment had 30% recycled content, recycled Nomex, as it turns out, in the blend, and we had 14% combined body burn. We had no idea how it would perform at 4 seconds. We had never done that before, but we were happy to go through. We were happy with the results. And what I don't show here is they had their Thermalman unit connected to some data that was printing out at the same time, and it was essentially a bar graph that would show you as a, if you're 25 years old and had 37% body burn, your chances of survival were 85%. If you were 65, you were 50%, something along those lines. And the board reflected that data at 37%. With ours at 14%, we were 100% survivability across the board. So we knew our product work, we just reinforced that we knew our product worked as performed, even at 4 seconds, which we were really happy about. And as a side note, the DuPont techie, once they flashed that, looked over at me and asked me, "How did you do that?" And I told them, "We're not telling him." That was my little gag for the day. So this year, this is ASTM F1930. This picture you see in front of you is the laboratory at the Protective Clothing and Equipment Research Facility at the University of Alberta. It's one of only 2 certified testing labs in Canada, and I think only one of 5 or 6 certified labs in North America. And I think there's 2 or 3 that have the ability to run a mannequin burn test. So this is this is our product. It was comprised of 73% meta-aramid, 30% of which was recycled, 20% monocrylic, 5% nylon, and 2% anti-stat. And this is simulating a 3-second incident flash fire, 800 degrees centigrade. The mannequin has a cotton t-shirt on it and cotton underwear, and they are measuring the combined 2nd and 3rd degree body burn. The pass and fail is 50%. The Canadian standard is 40%. The NFPA standard is 50%. This was the very first test that we ran on our product, going back to, I think, 2015, something along those lines. You're going to hear some voices in the background. That's some of our, that's one of our colleagues' kids. We couldn't be there, as a matter of fact, so we had them go in and film it for us. So this is the actual ASTM F1930 test. And I guess I should say, inside that NFPA 2112 standard, there's probably 11 or 12 test methods that we have to go through to get final approval. And they can range from, tear and tensile strength, abrasion resistance, crocking, wet and dry crocking, residual shrinkage. But the 3 biggies are, one, it's called vertical flame test, where they're taking a very small piece of fabric, just a few inches wide, on a wick. They are lighting it, and they are taking the flame away, and they're measuring how quickly that flame will self-extinguish, and the char and afterglow measurements of the fabric itself. The second test would be a thermal insulation test, where again they're taking like a 25-inch square piece of fabric in an oven, 500 degrees for 5 minutes. They're measuring the thermal shrinkage of that product. And then last but not least is the mannequin burn test, or the thermal insulation test. This is not a, if you get close to it, yeah, we'll let you go on. This is pass or fail. You either meet those standards, the minimums max, or you're out. So this is the first product we brought to market. We had to do the shredding. We did the yarn. We did the fabric, the dyeing, and the finish, and brought the garment to market. It cost us, that garment you're looking at in front of you is about $100,000. And we still didn't know if we passed the test, but we're about to find out. So that's aramid in its glory. So the data on this product was, we had 7.3% 2nd degree body burn only, 0 3rd degree burn. And so it passed with flying colors. You can see some thermal shrinkage at the bottom. The pant leg goes up on the ankle. Pretty normal stuff. But the product performed exactly as we expected it to. So 7.3% virgin product with the same material would be in the 18 to 19%. I'll take you to this next one, because one of our colleagues, his daughter is a burn specialist in the medical field. When she was one of the people filming this. This is a test that was done a few months later. When she saw that original burn test, she was horrified, and she couldn't believe that the pass or fail was 50%, because she felt that the standard didn't take into consideration so many factors that are critical for burn safety. And her point was basically, you know, if you get 50% burn, and we don't have to report, by the way, what our percentages are. So we're 7.3%. We're going to shout it from the rafters. But if someone had 45%, they're not going to say boo. They passed the standard, just like the guy at 7%, but they don't have to tell you. So that was a big concern for her, because the quality of life associated with those burns was going to change dramatically. So she looked at us and said, you know, it's great to have 50% burn on your chest or your back. You probably recover, yeah, and you're going to live, quality of life is going to be fine. But she said, what about the key burn areas would be your arms, your elbows. What if you can't bend your arms anymore because of serious burn injury? Or you can't bend your legs anymore? Or what if you burn 50% of your genitals? Your quality of life takes a nosedive. So we started building garments slightly differently to protect against that. I mentioned early in the process that we had a lot of waste material. So we took some of that waste material and we put an insert right at the elbow, right behind the knee. You can sort of see the knee pad there, and a piece through the crotch, so that we give some additional protection. Now, what you're about to see is a 5-second incident flash fire. This was strictly to be able to show where the material failed. We wanted to be able to tell people, yeah, okay, we're great at 3 seconds, and we can do this at 4 seconds, and here's our results at 5 seconds. We thought it would lend some assurance to the trade, and we tested accordingly. So this is a 5-second incident flash fire. Now, the first thing that comes to mind is 5 seconds is a long time. It scares the pants off me every time I watch that video. So you can see the color of the garment, right? It's, you know what, I'll roll it just a little bit more so you can see it, right? So you can see the, I chuckle to hear that too. So yeah, the garment is browner. So the cationic dye stuffs that are used to dye the aramids have burnt off. Okay, no big deal. The structural integrity of the garment was fantastic. So this product, it's important to note that nobody would survive a 5-second flash fire the way they're dressed here, right? Your lungs would be fried, you'd be toast. But in terms of performance of the garment on the mannequin, we had 21.5% second degree body burn only, 0 third degree burn. That's 100% better than the leading meta aramid product in the marketplace at 4 seconds. So we knew our recycled fiber was doing its job, and it really is a different animal. So if you look under a microscope at virgin fiber, it's going to be just perfect. It's going to be elongated, everything's nice, et cetera, et cetera. But because we chop the fiber up in our recycle process, we get a much more mangled sort of fiber content. And it's very uniform and consistent. And what it does ultimately is it creates thermal insulation through the yarn process. We created thermal pockets of air through the blending of the fibers. Better thermal insulation, better body burn data. And so we went back into the lab after this mannequin burn test, and we wanted to make sure we could repeat everything that we were talking about. And I'm thankful to say that it's continued to be excellent results all across. Doesn't matter what fabric we use, the body burn data has been exceptional. And that's only one component of it. The NFPA 70E standard that I mentioned is the electrical arc flash standard. So not only are we building this to be flash fire protective, but we're also conscious of the caloric energy protection per centimeter squared, right? The arc thermal protection value that comes off of that can give the arc flash protection. So, if you can be as lightweight as possible on a garment, better for the worker, of course, but we got to be sensitive to the risk hazard and the caloric energy that can output at any one hazard. And if you can be lightweight and achieve an HRC2, a hazard risk category 2 level of compliance, that's really a great place to be. And our product does exactly that, whereas many of the virgin products that are aramid based do not. So we achieved a higher level of certification. So this is what we do to help people along. We can do audits of their of their process, the collection, disposal costs, and how we can work that into the mix. Some companies, have central distribution. Some, particularly in the oil field services, they're all over the place. We can collect collection points at all kinds of different locations. We'll work with them so they're satisfied and their techies are satisfied on making sure the inspection is proper and there's no chemicals going back into the process. 20 to 30% would be the typical amount that we would start with. What you run into with shorter staple fiber is you're limited on the amounts you can put in, because you need to have a certain amount of strength in order to spin the yarns properly, and fibers get shorter, et cetera. There's some technical issues around that. So we've gone anywhere from 20% to 50% recycled content. Generally speaking, the coarser the yarn counts, the more recycled content we can input. But for something like the coveralls you just saw, 30%, 25-30% is pretty much the norm. The bottom point is really key to for end users to understand that we're not looking to upset their value chain. As I said earlier, it's to work with them. And their ace in the hole, of course, is always the third-party independent certification of the process, the very same testing methods. So the economics behind this are, why is it attractive for aramids? I guess I don't have to stay on this slide. Excuse me. Current meta-aramid fiber in the marketplace, virgin fiber, would be something in the $20 to $25 a pound range, right? $40 to $50 a kilo. I'm in the market at $10 a pound or $20 a kilo. So, I mean, including all of you right here now, an end user knows upfront that 25 to 30% of his input is going to be substantially, the input fiber into his program is going to be at a substantially reduced cost compared to virgin material. So there's an automatic savings, right through the value chain. And that's incorporating all the costs associated with recycling into the blend. So the economics make sense. And there's the hard part for the fashion side of the trade, the polyesters, the nylons of the world. Why doesn't it work? To me, it's really simple, and perhaps that's just the way I'm immersed in this every day. On any given day of the week, I can buy virgin polyester for $1.75 a pound. Recycled polyester is $3.75 a pound. There's your problem. Yes, there are technical limitations to recycled polyester that have to be factored in and overcome. Okay, fair enough. But it's costs more and people won't pay it. Simple as that. But with aramids, it's the complete reverse. It makes sense to recycle. The economics are there, right? So we make that case repeatedly. That's what I have.
Thank you so much, Dave. That was fantastic job.
No problem. See if I can get out of here now. I don't know how to get back to you, Ness. Sorry.
Let me see.
Okay, I gotta do that. I think I'm getting closer.
I think you should go back to that, like a share, or let me see. I'm not sure if I can cancel from my end here. Because
Yeah,
I don't want to shut down the whole.
Okay, there we go. There we go. I got it. Yeah. So that's what we do. I hope that's of interest to you guys. It's through the course of the back and forth on here, I was inadvertently put on copy to an email, and one of your AATC members was not interested in attending today, and he wasn't interested in attending because he thought this was to quote him, he said, a niche loser market. Now, I don't care if he's here or not. He can speak for himself. But this niche loser market by 2030 will be somewhere around $30 billion in North America, right? 30 billion. There's $5 billion of virgin meta and para-aramid fiber produced every year. 100% of it non-biodegradable. So niche loser, I don't know. I hate to think what the size of the market he thinks is viable to attack or not.
That's the kind of loser I want to be. I'd love to be that. And not to mention the specification of this fiber is done by people with money.
This
Right? I
is
mean, it just the story behind this is not consumer
no,
purchases. Yeah. So
no, exactly. And I'll finish with this, guys, if I can, before, and I'm happy to take some questions. I just happened to have Canadian Broadcasting Corporation radio on in the background the other day as I was polishing up some notes, and there was a chap talking about industry on there, and he said the following. He said the world needs new ideas, and I think we can all agree on that. But the world's immediate reaction is to always reject them because they're afraid of them. And I think there's some value in that. And he was encouraged people to dare, and the world will always yield. And I thought, okay, that's it's simple stuff, but I think it's important. The word recycled always brings up negative connotations for everybody. They fear the word. So here we are putting a product that has recycled content into the blend that's outperforming the virgin product. Outperforming, no question about it. And again, that third party independent certification is the ace in the hole for anybody who's worried about it, right? So education is a key component to what we do. I'm happy to do these kind of talks because it just helps spread the message. So I'm happy to answer any questions.
Dave, question.
Sure.
Can you hear me?
Yes.
Okay. So in terms of structurally, what is the difference between, I'm sure you did the structural analysis of the fiber, the virgin fiber and your recycled fiber. What do you see the big difference in terms of structural difference that really shows these results?
Well, we're mechanically shredding the process, right? We're shredding the product.
Correct.
And therefore we are shortening the staple. So
Okay.
a typical spun aramid staple fiber would be 51 millimeters. When we finish our process, we're at 26, 28 millimeters.
Okay.
So we have to blend it with virgin fiber in order to be able to spin the yarn properly. If we can't run production at an efficient level, that's just an obstacle the spinners would not undertake. However, and of course, by shortening the staple, we are shortening the fiber strength, and that's of critical importance, of course. But it only marginally impacts the strength of the fiber. Will it ever be as strong as virgin fiber? Never. But it's not to a degree that it will impact the performance vis-a-vis the standards that we have to live by. And again, the ace in the hole is that third-party identification. So it'll never be like virgin. It's a paradigm shift, no question. But is there functionality and a way to use this? Absolutely.
I think it's remarkable. I think it's definitely worth considering very seriously as to why not accept this as a real good product? Because
well, I tell you, because
shows.
the big names in the marketplace are worried about market share. Of course, they always are. I mean, we're a flea on an elephant's butt, right, in the big scheme of things. But the big name brands in the market, we would be competition. They would see it as losing 30% of the input fiber, rather than looking at a bigger picture and how this could open up opportunities. We're stuck in some of that mold with some of the fiber producers.
Yeah, but I think it's the consumer that really ultimately decides what to buy, where to, and if they're coming out cheaper, meaning less expensive, better performance, why not?
Yeah, well, and that's why we call on the end users. Now, and I want to be clear, it's not a race to the bottom, because even generic meta-aramid fiber is expensive. But can somebody save 10 to 15% on his garment program? You bet he can.
Absolutely.
Yeah, you bet he can.
Wonderful.
Dave, Audra Hunter, secretary of this chapter group. There was one question Harry Schutz had questioned in the chat. Incredible last statement that aramid recycled aramid costs less in its form as recycled. Could
Yes.
you give a little bit more detail as to how that is actually a factual statement? Or how does that happen? How is it cheaper?
Well, because I'm selling it. Well, I'm taking somebody's garbage and bringing it back to market, right? So it's not I'm not dyeing and finishing any product. There's no change there. I'm just taking garbage and I'm bringing it back into usable fiber, and I'm bringing it back to market at 1/3 of the price of virgin aramid. Now, you can't make a garment out of 100% recycled content because of the shorter staple fiber that I was just talking about. There are strength conditions we have to meet, et cetera, et cetera. But does 30% in a 6-ounce, 30% input in a 6-ounce coverall work? Absolutely. So you can pay $40, $50 a kilo if you want, or you could pay 20 for 30% of the fiber input. Now, how your value chain wants to margin along that and save an end user money, that's a discussion for somebody else to have. But I'm going to tell the end user that his fiber input is significantly cheaper. I can't count on the value chain to bring it forward.
Excellent. Thank you. One last question I had, and then I think we're getting close to time, but amazing innovations and some great thoughts that you brought to the table. You have a very wide variety of people on this, from consumers, from retailers, testing and quality assurance. What are, through your trials and tribulations that you've gone through this, what are some recommendations that you would have, or food for thought that you would have for anybody on this call as they're working through textile recycling?
Question. Well, I mean, again, so to your fellow members' comments about a niche market, it is compared to the fashion world, right? I can't. The magnitude of that problem is off the scale. It's a paradigm shift. It really requires an open mind. I'm never going to be like virgin product, but I'm going to be just slightly outside of that. So, and I'm going to introduce a product into the marketplace that eliminates your waste and brings it back to market. So there's that, open mind, open to new ideas. We had to create everything from fiber to fabric to new dyeing and finishing, and I can tell you, every step along the way, bar none, every so-called expert, knitting, weaving, dyeing, finishing, you name it, all of them said we were nuts. This would not work. And when we asked them why, not one of them could give us a good answer why it wouldn't work. And we took a flyer on it. We went forward. So here we are. We had to recreate the chemistry. We had to recreate the weaving, the dyeing, the finishing, you name it. We had to do everything. So paradigm shift, open mind. Don't be afraid to try something. I don't know if I get off track really easy.
No, that's good.
I don't know
Thank
if that
you.
answered it or
Good.
not.
Hello, this is Majid Sarmadi. What other physical properties were affected by the recycling compared to virgin material?
Yeah, well, the biggest notice was on the strength of the fiber, right? But really, we always knew we would have to blend it with virgin fiber, right? And it can be solution dyed fiber, or it could be piece dyed. We've done both, and they've both worked very well. Piece dye was a little trickier because the recycled fiber has already maxed out on the amount of dye stuffs that it could absorb. Although we had to input the same amount of dye stuffs as if it was 100% virgin product, but it wouldn't absorb it the same way. So in some colors, you can get a bit of a marled or a heather look, maybe like a denim look if you were dyeing navy, for example. But that's really no impact on the performance of the product. But we had to learn how to, it's all cationic dyes. Do we need to create a dye formula that also dyed the nylon, or the cationic dyes would stain the nylon? Is that good enough, given that the recycled fiber wasn't going to take any more dye stuffs? Or dye temperatures. Monacrylic is a very low temperature dyeing process. Aramids is a lot higher. So how do you find the balance to dye those products together? We had to learn all of those things. I'm happy to say we were able to achieve that. But I think the biggest point that customers will make to us, oh, is it recycled fiber? Is it the same strength? You know, we're really not worried about the performance. The performance has been absolutely fine. Education is key.
Did you come with a process to separate other fiber that they were in mixed with the garment that you received?
No, we didn't, and we don't. So if we get something like let me give you that. So, well, 9352, 93 meta-aramid, 5% para-aramid, 2% anti-stat is the typical Nomex 3A garment in the marketplace. That all of those fibers, all of those fabric will go into the box and run through the system. So what comes out on the back end is 9352. If we had 50% lensing FR, you know, 20% monocrylic and para-aramid blended together, that's going to be the blend that comes out in the fiber. So we're not taking we're not disassembling it in a, I don't even know if it's possible that we can separate out the particular components. It's rather it's a whole unit that goes into the box. That's what comes out on the backside. The virgin input on the fiber, we have total control over. So like baking a cake, we will create the recipe. Our recycling line gives us allowance to do that. So we can adjust our line all the way through the process to accommodate the type of material we're inputting. So we're creating a recipe, in fact, so that when you come around a second time with those garments, and by the way, everything we put in the marketplace can be recycled repeatedly. So everything we produce, we want back, and the cycle continues again. So we can go back to our settings from that original production, go back to the very same machine settings, tearing settings, so that we're uniform on the next bales of fiber that come out for you to recreate the process.
I think
One more observation, if I have time. You know, I worked with the state of California for coming with recycled carpets and all of those things. And later on, we made the specification in order to be minimum 25% recycled material. And then we find out that there was not enough clean recyclable items that can be used. So people were making defective bottles on purpose to sell it because there was a high demand for that. So do you think it will happen like that somebody is making, you know, that was kind of stupid to do that, but people were making defective bottles.
Right. Well,
converted to
the virgin aramid fibers are so expensive, Majid. I can't imagine somebody playing around with that. But now that you've mentioned California, I can't help myself. A lot of you will have heard that they have SB 707 in place now for textile recycling. They purposefully carved out industrial workwear. They know full well that they can recycle aramid product, and they carved it out. And the senator's office who sponsored that law told me, well, they couldn't figure out a good way to collect the garments from the industrial workwear sector. And of course, that's just bullshit. They just didn't look hard enough. So anyhow, so with all the focus directed on fast fashion and fashion industry, and I totally understand that. They're a long way from having circularity in that field. We should be the benchmark. We should be the prototype for all of them to be following.
Thank you.
You're welcome.
One quick question, Dave. So your system can also be adapted for military textiles too, right? Because some of them might be like a bulletproof vest, for instance. Have you tried that?
Well, our system is designed to handle para-aramids. I think I mentioned it off the top. And frankly, if you can handle para-aramids, you're not worried about anything else. So we're built for that. Military, we've done some recent testing for U.S. military contractors. their Defender M, their frontline operational camouflage garments. Yeah, was no problem to recycle. What we do with it after is still part of the R&D that we're going through. But yeah, we have no issues working with military, and Canadian military is also in the conversation now as well. Fortunately, they recognize they got a problem. All right, and most of these garments, once they're decommissioned, are just sitting in warehouses, and by the millions and the millions and the millions. So we're happy to help.
So more questions? So I leave, to Miss Akhtar or Chair to conclude the meeting, and if there is anything else we can add. This is just the first webinar. We wanted to start and see the practice, and hopefully we can continue this. And we would love to get your feedbacks. Feel free to share.
Do you mind if I say one comment?
Sure,
Thank you. We're also, I'd be remiss if I didn't say this. So we have a provisional patent on recycling thermal set plastics, right? I mentioned that in there, where we're playing around with new polymers and how we can input some of our waste product into new fiber. We're also working on PFAS, decontamination of PFAS on garments, where at the R&D stage, we're identifying PFAS on the garments, a process to remove the PFAS contamination, and then recycle that material back into the pipeline. That's a lot of the R&D work we're doing now. Structural firefighting is a key market. There's 2 to 3 million sets of turnout gear that will be turned over in the next 5 to 10 years. That's 30 million pounds of material. And once you factor in the waste fiber, you're probably more like 45 million pounds of material that is going directly to landfill. So with our eyes on that prize, if we can remove the PFAS to a degree that's to any degree, will be beneficial for everybody. So that's also the R&D we're working on.
Fantastic. Thank you, David.
You're welcome, Mass.
Thank you, everybody, for joining for our webinar. Thank you, Dave, for a very informative presentation. I appreciate all of you joining, and I would like to request everybody to please give your feedback and so that we can continue with our webinar series. This was our first webinar series from our section, and also give us feedback on our newsletter. And I thank everyone for joining us today.
Thank you, everybody.
Thank
It's been a
you.
pleasure.
Thank you.